So number 17 asks us to talk about the difference between K, Kp, and Q. Q is when you calculate the initial, the equilibrium expression with initial concentrations. Whereas K, you're calculating the equilibrium expression with equilibrium concentrations. And Kp is when you're using pressures at equilibrium. Number 20, which of the following statements is true? Correct the false statements. When a reactant is added to a system at equilibrium at a given temperature, the reaction will shift to the right to reestablish equilibrium. So if you're adding reactants, it will shift to the right. Whereas I would prefer to say products. So the answer for A is true. B, when a product is added to a system at equilibrium at a given temperature, the value of K for the reaction will increase when equilibrium is reestablished. Okay, so there's only one thing that affects K, and that is temperature. So K is a constant. So what's going to change are the equilibrium concentrations. These things change so that K stays the same. So if I add products, my reaction will shift left so that I can keep that ratio the same. So B is false. C, when temperature is increased for a reaction at equilibrium, the value of K will increase. That is true because, it depends. I was speaking too quickly. So K, for better or worse, is essentially a ratio of products to reactants. So when I increase the temp, it will change K. But how it changes K depends on whether the reaction is endo or exothermic. And that's why I wanted to go through number 67 in class. Because if your system is exothermic, increasing temperature helps the products or the reverse reaction more. Therefore, C and D will be able to get over that hump and become products. So what will that do to my ratio if more products are becoming reactants? K will decrease. If endothermic, increasing T will help the forward reaction. Therefore, more reactants will become products, and therefore K will increase. D, when the volume of a reaction container is increased for a system at equilibrium at a given temperature, the reaction will shift left to reestablish equilibrium. So once again, the answer is it depends. And I kind of talked about this a little bit. And number 67, it depends on the reaction. So here's V1, here's V2. So what's going to happen to my pressure? My pressure is going to drop. So the reaction will shift in the direction that will increase pressure to counteract the decrease in pressure due to the volume increasing. So you have to look at your reaction and see which direction is going to increase the pressure. So if I have 3 moles of gas A plus 1 mole of gas B becoming 8 moles of gas C, well, which direction is going to increase the moles of gas? If this is my reaction, shifting right would increase the pressure, because now I'm getting 8 moles of gas compared to 4 on the other side. But if my reaction was different, if my reaction was 3 moles of gas A and 1 mole of gas B, creating 2 moles of gas C, well, in that case, shifting to the left is going to increase P. So the answer to D is it depends. All right. Letter E, addition of a catalyst of a substance that increases the speed of reaction has no effect on the equilibrium position. That is true. The only thing that it changes K is temp, okay? So adding a catalyst speeds the reaction, but it just gets you to equilibrium faster. That's all it does. And the reason why this is, and it doesn't matter if your reaction's endothermic or exothermic, if you add a catalyst, it lowers the activation energy hill. But it lowers the hill equally for the forward reaction and the reverse reaction, okay? So because it lowers the hill the same amount for the forward and the reverse, it doesn't change the K, okay?